Oh, somebody forgot to do their homework. Okay, so welcome guys. I'm so sorry I didn't end up doing the plate tectonics reading homework for you or with you last night, so I'm doing it now. It is 6:46 in the morning on Wednesday, January 23rd, 2019. So I'm going to go through this quickly, and hopefully, most of you actually just tried it on your own, or if you didn't, you got about this amount of time in order to complete it before coming to class. Okay, so let's go. Don't worry about this part right here. You can answer those if you want to, not necessary. Okay, and then we'll scroll down here and go further, and I will begin the reading. Ta-da! Okay, it says the plate tectonics theory. When you blow into a balloon, the balloon expands. Its surface area also expands or increases. As more air is added to the balloon gets larger. Similarly, in ocean crust, if ocean crust continually forms at mid-ocean ridges and is never destroyed, Earth's surface should be expanding. But measurements of the planet show that Earth is not getting larger. How can this be explained? Geologists proposed a more complete theory in the late 1960s. It was called plate tectonics theory. The theory of plate tectonics states that Earth's surface is made up of rigid slabs of rock or plates that move with respect to each other, or in relation to each other. This new theory suggests that Earth's surface, the lithosphere, is divided into pieces of rock. These pieces are called plates. Each plate moves slowly over the hot and semi-plastic mantle. Ding! Remember, these keys tell you kind of where to find the answers. Number one, what is plate tectonics? If you're listening to this, remember, don't make a circle and draw an arrow. Write something out from what I circle into here. Okay? So here you go. What is plate tectonics? Dang, and we can start right here. Anything in there can go right here. Okay? Now, if you actually understood what I just did, after you finish writing in your answer right there, why don't you just go ahead and put a smiley face right over here, okay? And I will give points for that. Moving on to the next one. Oh, actually, I got to read this part down here. The word tectonics describes the force that shapes Earth's surface and the rock structures that form as a result. Plate tectonics explain why earthquakes occur and volcanoes erupt. When plates separate on the sea floor, earthquakes result and a mid-ocean ridge forms. When plates come together, one plate can move under the other. Remember the video we saw yesterday when plates are moving under the other or colliding together on the sea floor, creating earthquakes when they're pushing against each other. This causes earthquakes and creates a chain of volcanoes. When plates slide past each other, earthquakes can result, just like in the video we saw yesterday. It's basically describing what we saw in the video yesterday. Okay, Earth's tectonic plates. Ta-da! Okay, so in here, this is a map that shows you the boundaries and where tectonic plates are located. So it's like jigsaw puzzle pieces. Okay, so it says tectonic plates. Earth's surface is divided into rigid plates that move relative to one another. Look at the map above. It shows Earth's plates as their boundaries. Notice how some boundaries are in the middle of the ocean. They are. Some boundaries are in the middle. Yes, it is. Look at that. It's the boundary. It happens to be the Antarctic Ocean. Oh, that's Africa plate. Okay. And then look for plates in the middle of the ocean. Pacific plate. Okay. Yep. The Pacific and Antarctic plate is right here. So this is a plate that would be in the middle of the ocean. So you have the Pacific over here, right? And if you follow this side, the Arctic plate, 2 forms of water with a plate right there. That's what it's saying. Notice how some boundaries are in the middle of the ocean. Many of these boundaries are located at mid-ocean ridges. The Pacific plate is the largest plate. Ha ha! What I was saying. Bam! The Juan de Fuca is one of the smallest plates. Where's Juan? Oh, look at that! Okay, moving on. So if not, we'll stay on your sheet. Okay, Earth's outermost layers are cold and rigid compared to the layers within Earth's interior. The cold and rigid outermost rock layer is called the lithosphere. The crust and the solid uppermost mantle form the lithosphere. The lithosphere varies in thickness. It is thin below mid-ocean ridges. It is thick below continents. Earth's tectonic plates are large pieces of lithosphere. Ooh, that's a good test question. In fact, put a heart right here. These plates fit together like pieces of a giant jigsaw puzzle. Directly below the lithosphere is a very hot part of the mantle. This layer of Earth is called the asthenosphere. Even though it is solid, the asthenosphere behaves like a plastic material because it is so hot. The asthenosphere flows below Earth's plates and enables the plates to move. The way in which the lithosphere and asthenosphere interact help explain plate tectonics. Okay, ding! Check it out over here. By the way, some definitions right here you can use. What are Earth's outermost layers? So what are the two things we were just talking about? Kadam, right? And where's the other one? Kadam, okay? Going there. Moving on. And then it says, okay, oh, I'm going to accidentally put a video here. Take that out. Okay. So then it says, plate boundaries. Imagine placing two books side by side. Imagine that each book is a tectonic plate. Kind of like how we put the two graham crackers side by side yesterday. The place where the edges of the books meet represent a plate boundary. How many ways can you move the book along a set of boundaries? You can pull the books away from each other. You can push the books together. You can slide the books past each other. Each tectonics plate move in much the same way as you can move the books. And ding, ding, describe 3 ways in which tectonic plates can move. That is all in here. 3 different ways, okay? Here's the first one. Pull. You use actually small words. Pull, push, slide. I'm saying. Moving on. Divergent plate boundaries. We practiced this yesterday too. A divergent plate boundary forms where 2 tectonic plates separate. Divergent means moving apart. Mid-ocean ridges are located along divergent plate boundaries. When the seafloor spreads at mid-ocean ridge, lava erupts. As the lava cools and hardens, it forms new oceanic crust. As this process continues, the plates move away from each other. Divergent plate boundaries can also exist in the middle of a continent. At these boundaries, continents pull apart and a rift valley forms. The East African Rift is one example of a continental rift. Ding! 3 ways in which tectonic plates move. Oh no, we just did it, right? Oh, sorry, we're not at ding yet. Moving on. Transform plate boundaries. Okay, so we talked about divergent. Now we're talking about transform. The San Andreas Fault in California is a transform plate boundary. A transform plate boundary forms where 2 tectonic plates slide past each other. We practiced that yesterday too. As they move past each other, the plate might get stuck and stop moving. Stress builds up where the plates are stuck. When the stress is too great, the rock breaks and suddenly move apart. The result is a rapid release of energy in the form of an earthquake. You might want to remember, I don't know, for tests or something, that where do earthquakes come from, or how are they created? Through transform plate boundaries. Make sure just have an understanding the relationship between those two. Let's see. Next one, convergent plate boundaries. Here we go. A convergent plate boundary forms where 2 plates collide. I like the way some of y'all draw. The denser plate sinks below the more buoyant plate in a process called subduction, right? We saw that in the video. A subduction zone is the area where a dense plate descends, which means goes underneath, into Earth along a convergent plate boundary. The 2 types of convergent plate boundaries are ocean to continent or continent to continent. Ding! What are the 3 types of plate boundaries? Aha, 3 types. That's 1, 2, and 3. You know, go on there. Moving on. Feel free to pause the video. Do what you gotta do. Now we're going to talk about the 2 different types. 2 different types of convergent boundaries. Ocean to continent boundary. Excuse me. When a dense oceanic plate and less dense continental plate collide, the oceanic plate subducts or sinks under the edge of the continental plate. This creates a deep ocean trench and a line of volcanoes forms on the ridge of the continent. This process can also occur when two oceanic plates collide. An older and denser oceanic plate will subduct beneath a younger oceanic plate. An ocean trench forms along with a line of volcanoes. Continent-to-continent boundaries? Convergent plate boundaries also form when two continental plates collide. When this happens, neither plate is subducted. The less dense plate folds and reforms, forming a mountain such as the Himalayas. I remember that we practiced that yesterday too, using the graham crackers. Read and check. Here we go. Identify along what type of convergent plate boundary did the Himalayas form. Circle the correct one. Well, we know that happened to a continent-to-continent boundary. So continent-to-continent boundary. That's when they merge and go up. Evidence for plate tectonics. When Wegener proposed the continental drift hypothesis, remember that, we'll talk more about it today, technology was not available to measure how fast the continent moved. Remember that continents move apart or come together at speeds of only a few centimeters per year. This is about the length of a small paperclip. Today, scientists can measure how fast continents move. A network of satellites orbiting Earth is used to monitor plate motion. By keeping track of the distances between satellites and Earth, it is possible to determine how fast a tectonic plate moves. This system of satellites is called the Global Positioning System, GPS. Yes, that's how GPS is originally started, for NASA, of course. The theory of plate tectonics explains why earthquakes and volcanoes are more common in some places than in others. Recall that when plates separate, collide, or slide past each other, stress builds. When the stress suddenly releases, earthquakes can result. Volcanoes can also form along a mid-ocean ridge or continental rifts. They also form where plates collide along a subduction zone. Mountains can form where two continents collide. The map below shows that most earthquakes and volcanoes occur along tectonic plate boundaries. Here. Now with this information, and up here, we can answer this. Okay, key concepts, right? This one. How are earthquakes and volcanoes related to the theory of plate tectonics? Okay, so what happens with the earthquakes or how the earthquakes are formed? Let's go back. For earthquakes, so I would use this little part, meaning earthquakes and volcanoes. You can use that sentence. Shorten it up, do what you got to do, put it here. Visual check. Do earthquakes and volcanoes occur anywhere away from plate boundaries? If so, where? So let's look at the graph. Okay. Do earthquakes and volcanoes. Look. Active earthquakes, right? Volcanoes. And that white line, if it's like a white line, it means plate boundary. Let me see if I can make it bigger. Okay, there it is. So do earthquakes and volcanoes occur anywhere away from plate boundaries? Alright, so here's our plate boundaries. Do you see any earthquake and volcanoes? You're basically looking for circles and triangles. Okay, away from the plate boundaries. If you notice, what we're seeing is that all of the earthquakes and volcanoes are near plate boundaries, right? Basically, all the triangles and circles are close to a line or on a line, aren't they? And the plate boundary, doing double check. Wait a minute. I'm thinking that this may be this might be a possible answer because it's not really close to a boundary. It's like in the middle of the ocean, we see a lot of active volcanoes. Like here, see what I'm saying? So I would put here, middle of oceans. Tired. Now I'm thirsty. Somebody bring me some McDonald's for breakfast. Oops. Yeah. All right, moving on to the next part, plate motion. Okie dokie. You learned that the main objection to Wegener's continental drift hypothesis was that he could not explain how or why Earth's continents move. Scientists now understand that continents move because the asthenosphere moves underneath the rigid lithosphere. I'm going to talk more about Wegener today. Convection currents. The circulation of materials caused by differences in the temperature and density is called convection. And for example, the upstairs floors of homes are also warmer because hot air rises. We all know that hot air rises, right? Hot air is less dense than cold air, and that's why it happens. And so that is called convection. Okay? What causes convection? Bam, there it is. An example would be, hot air rising in a house. That would go here. Okay? Let's see. Oh, I've already been 16 minutes on this. What's left? Lord Jesus. Okay. Okay, so let me speed this up a little bit. The question is, why do tectonic plates move? Okay, you're on your own with that because I just started reading myself. Alright, you guys can get it from here. And you can do this one. This one and this one on your own. Going down here, a slab bowl. Okay. A theory in progress. Ooh, the math skill. This is what we're going to do. Don't worry about this one. Don't worry about this one. And you're reading. That you can do on your own. This one, do on your own because it's your opinion. So any answer you put right here would be correct. And bam, I want you to do this part too. Review the terms and their definitions in a mini glossary. That's this up here. Choose one term and explain what it means in your own words. Okay, so I get to choose one term and explain what it means in my own words. All right, so I'm going to do convection. And I know convection is the circulation of materials caused by differences in temperature and density, right? So in my own words, I would say convection. Remember, I'm just doing a definition in my own words. Temperature change happens. And it affects density. Okay? Oh, Lord Jesus. So you take one of these words and do the same thing. Read it, reword it, make it your own. I was probably going to take my word. I know. This one, use what you have learned about plate tectonics to complete the concept map. Ooh, okay. All right. So plate boundaries, we have convergent. So two things are going to spring off from convergent and two different types of plate boundaries. Let's go back up here. What are the two different types of plate boundaries? And you have convergent plate boundary, divergent plate boundary, right? Transform plate boundary. Convergent's already used, right? Because there's two types of convergent. So go back up, and you should be able to tell me plate boundaries. Boom, boom. If you're not sure, just from looking at the vocabulary, let's just go back up here. Oh, here we go. Plate boundaries. Oh, I still had that circle. What? Divergent and transform and convergent. Let's see which one goes where. Now I'm confused. I'm trying. Some convergent. I'm gonna do this one with you. I'm not pausing this and recording to try to make it better. I don't got time for that. Continent, convergent, and there's two. Continent to continent. Then go here. Those are two types of convergent. I'm gonna open up another page so I can see it. Convergent. There we go. I was like, worst video ever. Ocean to ocean, ocean to continent, continent, boundary, or continent, continent to continent. This would be easier. Plate boundaries here. So that means these should automatically be the divergent and the transform. Divergent. And transform. All right, that's as good as it's gonna get for today, guys. So be careful when you come in today. I'm tired. I got lots going on, but still loving class. Love you guys. I'll talk to you later.